Today we're going to talk about functions. A function, f, is a map from one set, which we call the domain, to another set, which we call the range, that assigns to every element x in the domain exactly one element y in the range. So that's the definition. Let's draw some pictures so we can really understand this visually. So we're going to have two sets. Let's say this is set A and this is set B. So sets are just collections of objects. So you can put whatever you want in your first set. You could put the number 4. You could put the word dog. You could put a star in set A. So whatever you want, just a collection of objects. And then you're going to put some objects in B. And you can repeat the same objects. Let's go with the number 2. Let's put a circle and the number 8. So a function is a map that takes every element in set A and assigns it to one element in set B. Now there's several ways to assign elements. What I'm doing is I'm saying 4 is going to be sent to 2, star is sent to 0, and dog is sent to 8. This map here is our function f. Another way we write this is we say 4 maps to 2, star maps to 0, and the word dog maps to 8. Sometimes we'll put the letter f above it to say this is corresponding to this function. So we have a function that'll send 4 to 2 and star to 0 and dog to 8. Another way we represent functions is by ordered pairs. So you see how we have 4 goes to 2? You could also write it like this: 4 comma 2, star comma 0, and dog comma 8. So this ordered pair representation is saying that 4 is going to 2, star is mapped to 0 by the function f, and dog is mapped to 8. Normally, when we talk about functions, we're actually going to deal with real numbers. Of course, you can put whatever you want in your sets, but in this class, we're going to work with numbers. And again, I also want to remind you that this first set is the domain, and the second set is the range. Now I'm going to show you some maps, and we're going to figure out if they're functions or not. Okay, so let's say our domain consists of 7, 3, 4, and 2. And I'm going to let my range be 1, 8, 3, and 4. So tell me if this is a function. We're going to send 3 to 1, 2 to 3, 4 to 4, and 7 to 8. Is this a function? In fact, we're going to say, is f a function? Where f is this map here. This is my domain, and this is my range. So the answer is yes. Let's look back at the definition really quick. So it says that every element in the domain is sent to exactly one element in the range. Is that happening here? The answer is yes. So it is a function. Okay, let's try something different. What if I send, actually let me change some of these numbers. I'm going to make this 5, 0, and 9. Now I'm going to let f be the following function. I send 3 to 1, 2 to 5, and 7 to 0. Is this a function? This is not a function. Why is it not a function? Again, the definition said that every element in the domain, all of the elements we see, they are each sent to exactly one element in the range. Here, the number 4 is not being sent to anything. And because it's not being sent to a number, this is not a function. Okay, let's try a different one. We can use other letters for functions too. This time I'm going to call my function g. Now this is just another name for my map, the map that I'm going to give you. So let's say 3 goes to 1, 2 goes to 5, 2 goes to 9, and 4 goes to 0. Is G, this following map, oh, and I think I forgot one, also number 7. Let's add another number in here. Let's make this -1. And let's send 7 to -1. Is this a function? Well, the answer is no. Why is it not a function? Well, let's look at everything. We have 3 being sent to 1, that's fine. 7 is sent to -1, that's okay. 4 is sent to 0. But here I'm taking 2 and I'm sending it to 2 different elements in the range. Let's scroll back up to the definition. It says that every element is sent to exactly one element in the range. So that's where the problem is. I'm sending I'm sending one element to 2 things in the range. So it's not a function. Let's define G a different way. Let's say we send 3 to 1, 2 to 5, 7 to 0, and 4 to 9. And let's call this the function, or let's call it G. And let's figure out if it's a function or not. So is this a function? Notice that -1 is in the range, but nothing's being sent to it. Is that okay? Is that allowed in our definition? Remember, the definition says that every element in the domain is sent to an element in the range. It doesn't say that every element in the range has an element in the domain that's being sent to it. So this is a function, even though there's something being left out in the range. That's okay. You just can't leave anything out in the domain. Okay, let's try another one. Let's call the next map H. I'm going to send 3 to 1. I'm also going to send 2 to 1. I'm going to send 4 to 9. And let's send 7 to 0. Is this map a function? Well, let's see if it follows the definition. Is every single element being sent to something in the range? The answer is yes. Is every single element in the domain only being sent to one thing in the range? The answer is yes. Notice that 3 and 2 are both being sent to 1, but that's okay. We didn't say that every element in the range has exactly one element in the domain that's being sent to it. We said every element in the domain is being sent to exactly one element. So as long as it follows the rules, then it is a function. So the answer is yes.